Bismillahirrahmanirrahim. Assalamu alaikum, ladies and gentlemen. I hope you are here and healthy. Today we are going to talk about a very interesting topic, that is the molecular orbital theory for octahedral complexes. We will explain different examples, but in this lecture we will discuss only one example of the strong ligand. So in octahedral complexes, you know that the coordination number is 6 and the geometry of that is octahedral. So you can see this, the coordination number is 6 and the valence is also called, the secondary valence is also known as the coordination number. So these both are same and the geometry will be octahedral. So in this case, octahedral complexes, they may be formed of the weak ligand or of the strong ligand. So if we check in this example the strong ligand, for the weak ligand we will talk in the next lecture. So this is potassium hexacyanocobaltate 3. In case of X, if it gives us ions, if this gives ions, then it will give this complex of negative charge. Now as you know that atomic number of cobalt is 27. So this electronic configuration will finally give us 4:3d7. As you can see, this is in the +3 oxidation state. So this will give us 4s0 3d6. Now you can see this electronic configuration of 4s. This is 3d, and there is the 4s, and there is the 4p. You know very well that this D has 5 orbitals, 1, 2, 3, 4, 5, and these electrons are filled in the degenerate system 1, 2, 3, 4, 5, and 6. Now you can see that there is the presence of strong ligand, as the ligand attached is cyano, and the cyano and ammonia, these are strong ligand, and the fluorine, these are the weak ligand. Weak ligand we will talk in the next lecture because there is some other problems. So in this lecture we will only talk about the strong ligand. This is called strong ligand. So this will cause the pairing of these electrons. So this pairing will be in the form of this structure. Now this is the 3d, 5 orbital, 3, 4, 5. Then the pairing occurs. It will give us 3 filled d orbital, and the 2 will be remaining empty. So this pairing, this cyano will donate its lone pair to these orbitals. As you know that these are 6 orbitals, so this will donate their electron in these 6 in this form: 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and 6. You know that this electronic configuration and this hybridization is due to sp3. This is the octahedral configuration of this hybridization is for this octahedral complex. Now we are going to talk about the MOT of this. As you can see, there is a presence of dz square, dx square, s, and 3p. In most cases, if you know about the group theory designation, then in that case we call S as A1G and PX, PY, PZ, T1U, and this DX, DY, DZ as T2G, and this DZ square, TX square minus Y square, and DZ square, this is called as EG. Now as you can see, there is the presence of 3D, 4S, and 3P. Now we will make it as like so: 1, 2, 3, 4, 5. This is the 4D, the 3D. This is the 4S, and this is the 4P. Now you can see there is also the presence of 6 ligands, which is in lower energy and then this 3D. So we will make these here 4, 5, and 6. Now you can see this have 6 lone pairs. Then 1, 2, 3, 4, 5, and 6. As you can see, this in this case only the dz square and dy square, dx square and y minus y square and dz square make bond. So this will give us over here. And but before this, first of all, let's make for this. So these are the 4s made over here. So you can make it like so. This is, and first as long there is a field over here, so 2 electron will be filled there. Now the second for the 4p, and where is the presence of the bonding, there will be the presence of anti-bonding. So there will be form an anti-bonding above this, and it will make, yeah, this is the possibility and probability. We will talk in next lecture about this. So this is made empty because the bonding formed, and for this P here is made, this is made. Three P. 1, 2, 3. So 3 will be filled 1, 2, and 3. Now also it will make an anti-bonding. That is 1, 2, and 3. It will be made over here. Similarly, as you know that all the d orbital remain on non-bonding and only 2 make bond. So this 2 will give us, the 2 will be over here. These are the dz square, x square, z square, which are known as Eg, and there will be the presence of its anti-bonding, which are over here. These are A star G, and there are the 3, these are remaining, which is Eg plus T2G. Then these 3 of will remain non-bonding. These are called T2G. So as you can see, the electron over here is R6, 1, 2, 3, 4, 5, 3, 4, 5, 6. This is the configuration over here. But after pairing, we got the all the electrons, and it's 2G because this Cn will cause the pairing of it. So you can get the all the 6 electrons over here. So now you can see the 2 also made the bondings of the 2 lone pair also found in over here. So these 2 will shift it to there. Now these are 2, 6, and 10, 12. And these 12 complete electrons are filled over there. So, and these are lone pair. This non-bonding is remain T2G, and this anti-bonding of this E star G, and this is T1U. This is T star U. No, sorry, this is the A1G. This is A star 1G, and this is T star 1U. That's all about the MOT for this octahedral complex of strong ligand. We will talk in the next lecture of the weak ligand, and as well as in the next lecture we will talk about the octahedral. Hope that it works properly. If there is any confusion, you may ask. Allah Hafiz.